For today's lesson, our focus standard comes from Grade 7, Statistics and Probability, Standard 7. Compare probabilities in uniform and non-uniform models. Our topic comes from our probability unit, and the title of this video is Uniform versus Non-Uniform Models. Our essential question is, how can we compare probabilities in both uniform and non-uniform models? Please take a moment, pausing the video if you need to, copy down the topic and essential question into your header, along with today's date, set up your question column and your note column, and resume the video when you're ready to begin. So as we look at today's lesson, we're talking about uniform and non-uniform probability models. So the question is, what do we mean by uniform models and non-uniform models? The short answer to that is basically looking at, are all possible outcomes equal? And if all the possible outcomes have an equal chance, meaning it's more of a fair game, then that would be a uniform model. However, if they don't all have equal chances, if some have a better chance than others in all the possible outcomes, then they're not equal chances, and that would be a non-uniform model. So let's take a look at a spinner example. So let's say we're playing a game, and we're going to use one of the two spinners. Which spinner is uniform and which one is non-uniform? So using our definition up here. In which one do all the possibilities have an equal chance? And in which spinner are they not an all equal chances? What do you think? Well, on spinner A, we have 4 possibilities, and they all seem to take up about 1/4 of the spinner. Over here, for spinner B, we have 3 possible outcomes. 2 of them take up about 1/4 of the spinner, but blue takes up half of the spinner. So which spinner, A or B, is uniform, and which one is non-uniform? If you said that A was uniform, I would agree with you, because all the possible outcomes of the 4 have an equally likely chance of getting spun. For spinner B, blue has a much bigger chance. It has half of the spinner, whereas green only has 1/4 and purple only has 1/4. Example B would be non-uniform because blue has a bigger chance than the other 2 possible outcomes. So let's do a little more work with this. So uniform, they all have equal chances. Non-uniform, at least one option has a better chance than the others. Now we're going to make a probability model for our 2 spinners. And a probability model is just listing out what is the probability for each possible outcome. So you can list this out in fraction, decimal, or percent form. I'm going to do all 3 just to show that. But I want you to pause the video if you need to and fill in these blanks. What is the probability on spinner A of getting a green, a purple, a red, and what's the probability of getting blue? So you're going to write that out. And again, you can use fractions, decimals, and percents. And then the same thing for spinner B. Of the total spinner, what is the probability of getting a green? What is the probability of getting a purple? And what is the probability of getting a blue? So take a moment, pausing the video as I mentioned, and see if you can fill in these blanks. And then let's compare our work. Alright, so looking at spinner A, I'm looking at this and I could divide it into fourths, and they all have an equal chance. So the probability of green in fraction form would be 1/4, which as a decimal is 0 and 25 hundredths, and as a percent is 25%. And that is green right here. and blue, purple, and red would all match that. So I went ahead and put the probability for each color as being 1/4 or 0 and 25 hundredths or 25%. And that would match what we see up here. They're all equal, which is what makes spinner A uniform. They all have the same values here for their probability, or their likelihood. Now let's take a look at spinner B. Well, green, if I split this, I could split that up into fourths, and green would take up 1/4, which is still 0 and 25 hundredths, or 25%. That would be the same for purple. So I used that same probability for purple, because again it takes up a 4. But for blue, what are we going to put there? What did you put there? Well, I put 1/2, because it looks like it's split down the middle and takes up half of that spinner, which is 0 and 5/10, which is equal to 50%. Here we notice we see the probability as being 25%, 25%, and 50%. They don't all match. They're not all equal. So that is what makes, again, spinner B non-uniform. Each of the 3 outcomes do not all have an equal chance. So this is a non-uniform probability model. Let's look at one last thing. Take a moment to answer this question about each of our 2 spinners. What is the total of all possible outcomes for each spinner? When we take the total of the probabilities, what does it add up to, or what's the total sum? Go ahead and write that down for spinner A and spinner B. For spinner A, each of them are 0 and 25 hundredths. If I multiply that by 4, I get 1/2, which is the same as 100%. So adding up all the probability for green, purple, red, and blue, I would get 1/2 or 100%. That's a really important thing to notice. Is that also true of spinner B? What happens when we add up 25 hundredths and 25 hundredths and 5/10? What do we get? Well, if we add that up, we also get 1/2, which is equal to 100%. This is an important thing to notice because we're also going to start talking about, is this a valid probability model? Are we accounting for 100% of the possibilities? And so, as I mentioned, that's an important thing to notice because it tells us that both spinners, although spinner A is uniform and spinner B was non-uniform, both are valid models because all the possible outcomes add up to 1/2, which is equal to 100%. We're taking into account 100% of the possibilities, so it's a valid model. That's going to conclude our video for today. Leave room for your summary, make sure your notes are complete, and come ready to discuss more of these types of problems